F-15E Strike Eagle. How a non-stealth jet survives modern radar. The F-15E Strike Eagle is not invisible. Every modern radar system can detect it. Every infrared sensor can track it. Every advanced air defense network can see it coming. And yet, it continues to operate in some of the most dangerous and contested airspace in the world. So how does a fully visible fighter jet survive in an era dominated by stealth technology? And why hasn't it been replaced completely by aircraft designed to avoid detection? Let's start with the biggest misconception. Detection does not equal destruction. Being seen does not automatically mean being shot down. The F-15E Strike Eagle proves that reality is far more complex. Here is the truth. The aircraft was never designed to be stealth. Unlike newer platforms, it does not rely on shaping to deflect radar waves. It carries external weapons that increase its radar signature. It is powered by engines that generate significant heat. On paper, it should be one of the easiest aircraft to detect, and in many ways, it is. Modern radar systems can identify large aircraft shapes from long distances. They use multiple frequency bands to build a more complete picture of the sky. Low-frequency radar can detect the presence of an aircraft, even if it is optimized for stealth. High-frequency radar provides more precise tracking and targeting data. The F-15E appears clearly in both. It reflects radar energy rather than dispersing it. So detection is not the challenge. Tracking is not the challenge. Even engagement is not necessarily the challenge. Now, here is what most people get wrong. Modern air defense systems are not a single radar and a single missile. They are complex, layered networks. One system detects, another confirms, another tracks, another launches. All of this is connected through data networks that share information in real time. Long-range radar systems monitor large areas. Medium-range systems provide tracking and targeting. Short-range systems protect key assets. But radar is only part of the story. Infrared sensors play a critical role. These systems detect heat instead of reflected radio waves. Jet engines produce intense thermal signatures, especially under high thrust conditions. The F-15E has two powerful Pratt & Whitney engines. Each generates up to 29,000 pounds of thrust. That heat is visible from dozens of kilometers away. So again, detection is not the limiting factor. The aircraft can be seen, it can be tracked, and it can be targeted. Yet survival still happens. This is where the concept of survivability becomes critical. Survivability is not about avoiding detection entirely. It is about managing risk across multiple stages of engagement. The F-15E was designed with this philosophy in mind. Let me give you a concrete number. The F-15E has a radar cross-section, or RCS, of roughly 10 to 15 square meters. That is about the size of a large truck. A stealth fighter like the F-35 has an RCS of approximately 0.001 square meters. That is closer to a marble. So the F-15E can appear 10,000 times larger on radar than an F-35. That sounds terrible. But here's the counterintuitive part. The F-15E does not try to hide. It relies on a combination of speed, altitude, electronic warfare, and coordination. Speed reduces exposure time. If an F-15E flies at Mach 1.2 through a threat zone, it covers 400 meters per second. The faster it moves, the less time enemy systems have to detect, track, and engage. Altitude also changes the game. Operating at different altitudes affects how radar waves interact with the aircraft. Low altitude uses terrain masking. High altitude increases detection range, but also allows faster response. Electronic warfare is one of the most important factors. The F-15E is equipped with systems designed to interfere with enemy radar. This includes jamming, which introduces noise into radar systems, and deception, which creates false targets or alters the perceived position of the aircraft. These systems do not make the aircraft invisible, but they make it harder to track accurately. And in modern air combat, accuracy is everything. A missile does not need to know that something exists. It needs precise targeting data to intercept it. Even small errors can result in a miss. Here's a real-world example. During operations in the Middle East, an F-15E crew detected an incoming surface-to-air missile launch. They did not turn invisible. They deployed chaff to confuse radar. They released flares to distract infrared seekers, and they executed a 7G turn. The missile missed by approximately 50 meters. Detection did not kill them. Physics and countermeasures did. Decoys add another layer of protection. Chaff consists of tiny aluminum or zinc fibers. When released, they create a cloud of false radar returns. Flares burn at temperatures higher than the aircraft engine. They pull heat-seeking missiles away from the real target. These countermeasures create uncertainty for incoming threats. They force the system to make decisions under imperfect information, and that increases the chance of survival. But the most important factor is not the aircraft itself. It is the network it operates within. The F-15E is rarely alone. It is part of a larger system that includes other aircraft, support platforms, and ground-based assets. Airborne early warning systems like AWACS provide a wide area view of the battlefield. They detect threats at long distances and share that information with other units. This allows the F-15E to adjust its path before entering the most dangerous zones. Electronic warfare aircraft can degrade or neutralize hostile radar coverage. They interfere with radar functionality and communication networks, reducing the effectiveness of the entire defense structure. Fighter escorts provide protection against enemy aircraft. They engage threats before they reach the strike platform. All of this creates a layered offensive system that mirrors the layered defensive system. Instead of one aircraft facing one defense system, it becomes a network versus a network. And in that environment, detection is only one part of the equation. Timing becomes critical. Operations are planned to exploit gaps in coverage. Routes are selected to minimize exposure. Attacks are coordinated to overwhelm defenses. Multiple assets may engage simultaneously, forcing the defense system to divide its attention. The F-15E is also designed for flexibility. It can carry a wide range of weapons. It can adapt to different mission profiles. Standoff weapons enable engagement from outside the most dangerous zones. Instead of flying directly over heavily defended areas, the aircraft can launch from a distance. Some air-to-surface missiles have ranges exceeding 100 kilometers. That keeps the F-15E outside short-range air defense bubbles. Another factor is payload capacity. The F-15E can carry up to 23,000 pounds of ordnance. That is roughly 10 tons. This means fewer aircraft may be required for certain missions, reducing overall exposure. It also means each sortie can deliver substantial impact. So why hasn't stealth completely replaced non-stealth aircraft? Because stealth has trade-offs. Internal weapon bays limit payload. Radar-absorbent materials require careful maintenance. Cost per flight hour is significantly higher. The F-35 costs approximately $40,000 per flight hour. The F-15E costs around $25,000. For missions that do not require penetrating the most advanced air defenses, the F-15E makes economic sense. Modern warfare is evolving rapidly. New technologies are constantly changing the balance. Advanced radar systems are becoming more capable. They use multiple frequencies. They integrate data from multiple sources. They apply advanced processing techniques. Infrared systems are improving as well. They are becoming more sensitive, more accurate, and more resistant to countermeasures. Artificial intelligence is beginning to play a role. It can process large amounts of sensor data, identify patterns, improve tracking. All of this makes detection more reliable, but it also makes the environment more complex because the same technologies can be used on both sides. Electronic warfare systems are becoming more advanced. They can adapt in real time. They can respond to changing conditions. They can target specific threats. Networked operations are becoming the standard. Data is shared across platforms. Decisions are made faster. Responses are coordinated. This creates a dynamic environment where advantages are constantly shifting. In this context, the idea of a single dominant technology becomes less relevant. There is no perfect solution. Every system has strengths and weaknesses. Stealth reduces visibility, but it often comes with trade-offs in payload or cost. Non-stealth platforms are more visible, but they can offer greater flexibility and capacity. The F-15E continues to operate because it fits into this evolving system. It is not trying to be invisible. It is designed to be effective. It leverages speed, coordination, electronic warfare, and strategic planning to operate in environments that appear extremely dangerous. This is why the concept of detection must be understood differently. Being detected does not mean being defeated. It means entering a complex interaction between multiple systems, where outcomes depend on many variables: technology, tactics, timing, coordination. All of these factors interact in ways that are difficult to predict. And that is what defines modern air combat. It is not a simple equation. It is a constantly evolving system, where advantages are temporary and adaptation is essential. The F-15E Strike Eagle is a product of this reality. It does not rely on invisibility. It relies on integration. It operates as part of a larger network. It uses multiple layers of protection, and it continues to prove that survivability is not about avoiding detection. It is about operating effectively within a complex and contested environment. As new technologies emerge, this balance will continue to shift. Future systems will become more advanced. Detection will improve. Tracking will improve. Weapons will become more capable, but countermeasures will evolve as well. New forms of electronic warfare will be developed. New tactics will emerge. New platforms will be designed. Each generation will respond to the challenges of the previous one, and the cycle will continue. This is what makes modern military aviation so complex and so dynamic. It is not defined by a single breakthrough, but by continuous adaptation. The F-15E Strike Eagle remains relevant not because it is invisible, but because it is part of that evolution. It demonstrates that even in a world of advanced detection systems, there is still space for platforms that rely on a different set of strengths. And as long as warfare remains a contest of systems rather than individual technologies, that approach will continue to matter. If you want to understand where air combat is heading, you need to look beyond simple ideas like stealth versus non-stealth. Focus on the interaction between detection, tracking, and survivability, because that is where the real story is unfolding, and it is far from over. Subscribe to follow the evolution of modern military aviation, advanced fighter jets, radar systems, and the technologies shaping the future of air combat.